As Chinese stealth jets roll out of near-dark factories almost non-stop, is Beijing quietly preparing not just for a Taiwan flashpoint, but for a long Pacific air war where sheer numbers decide who owns the skies? With J-20 stealth fighters now being mass-produced at industrial scale, is American air dominance over the Western Pacific facing its most serious challenge since the F-22 first took off? If AI-run dark factories are building frontline fighters almost around the clock, has China just shifted the contest from who has the best jet to who can keep churning them out in a grinding war? If Beijing really pushes toward a fleet nearing 1,000 J-20s by 2030, does the Dragon start to match, or even overshadow US F-22 and F-35 numbers over Asia's key battlefields? With Taiwan tensions already high, China's AI-driven dark factories are now mass-producing J-20 stealth jets almost around the clock, turning fighter output itself into a strategic weapon. J-20 airframes are increasingly assembled inside automated plants where artificial intelligence coordinates production lines, making the jet as much a software product as a traditional airframe. One plant linked to Chengdu reportedly runs nearly 21 hours a day with minimal lighting and skeleton human crews, relying on machine vision and networked robots to keep the lines moving. Inside, autonomous vehicle shuttle wings and fuselage sections between stations, while AI-guided robots handle welding, drilling and fastening in near darkness. Strategists say Beijing is trying to shift the race away from who has the single best jet or pilot, and toward who can outproduce and sustain stealth fleets through a long attritional conflict. Autonomous guided vehicles move fighter components along the floor without human drivers, feeding parts directly into robotic workstations. AI-controlled machinery coordinates production through machine-to-machine networks, adjusting tempo and sequencing in real time. Critical J-20 fuselage sections are produced in near darkness to boost efficiency and reduce energy costs, with sensors doing the seeing instead of people. A unified machine language links robotic systems across the chain, allowing welding, drilling and inspection stations to sync up automatically. The automation cuts downtime and removes classic industrial bottlenecks, squeezing more finished jets out of the same square footage. Human involvement inside some production zones has reportedly dropped by around 80%, turning staff into overseers rather than hands-on workers. Machinery is said to operate more than 21 hours a day at peak tempo, leaving only short windows for maintenance and reconfiguration. China first trialed dark factory concepts in sectors like BYD's EV lines and Xiaomi's electronics plants before scaling them into aerospace. Open-source estimates suggest China now fields more than 300 J-20s, with roughly 320 to 350 aircraft expected to be operational by the middle of 2026. Current output is believed to have climbed to around 100 to 120 J-20s a year, meaning China could be rolling out more than 2 stealth fighters every single week. Massive expansions in shop floor space, measured in millions of square feet, point to long-term fifth-generation scaling rather than a handful of symbolic demonstration jets. Analysts warn that if these trends hold, a fleet edging toward 1,000 J-20s by 2030 could rival combined F-22 and F-35 numbers available to the US in the Pacific theater. China's new WS-15 engine gives the J-20A more thrust, greater range and improved payload options compared with the stopgap power plants used on earlier production blocks. China began serial deliveries of WS-15-equipped J-20 as by late 2025, marking the start of a new performance tier for the fleet. The WS-15 is reported to generate thrust in roughly the 18.5-ton class, boosting climb rates and speed. Extra power improves acceleration, payload flexibility and high-altitude flight, letting the jet carry more weapons or fuel without feeling sluggish. The engine enables sustained supercruise, supersonic flight without relying on fuel-hungry afterburners, over extended distances. Reduced afterburner use lowers infrared emissions during long-range missions, helping preserve the aircraft's stealth profile. With this engine, J-20s may be able to hunt targets farther out over Pacific approaches, pushing their engagement envelope deeper. The WS-15 also sharply cuts China's reliance on imported or foreign-derived engine technology, closing a long-standing gap in its aerospace sector. Many analysts call WS-15 maturity a major turning point for China's Air Force, because it unlocks the J-20's full design potential. A two-seat J-20s variant is being built to manage drone swarms, electronic warfare tasks, and networked strike coordination, essentially turning one stealth jet into an airborne battle manager. Beijing's concept is for J-20s cockpits to act as flying command hubs, directing unmanned loyal wingmen, standoff missiles and jamming assets from inside contested airspace. China publicly unveiled the two-seat J-20s around the 2024 Zhuhai Air Show, signaling it was ready to show off more than a paper design. The jet is tailored for manned-unmanned coordination missions, where the backseater manages drones and data while the pilot flies and fights. In battle, J-20s could direct drone swarms handling reconnaissance, decoys or electronic warfare roles, keeping the main jet away from some of the riskiest tasks. The concept treats stealth fighters as airborne command centers, not just shooters, placing them at the heart of a wider network of sensors and weapons. The aircraft integrates advanced radar and AI-enabled avionics to sift through massive data streams and assign tasks in real time. Engineers are also testing enhanced stealth coatings and enlarged internal weapons bays to keep more weapons hidden inside the fuselage. The platform reflects Beijing's shift toward fully network-centric air combat, where information sharing can matter as much as raw speed or maneuverability. Analysts see the J-20s as a key building block in China's future autonomous warfare doctrine, bridging today's pilots with tomorrow's AI wingmen. China is already flight testing at least two sixth-generation fighter concepts, the J-36 and J-50 families, suggesting it wants parallel paths into the next era of air combat. The larger J-36 concept reportedly focuses on long-range, big payloads and deep stealth in a tailless, heavy-lift configuration optimized for Pacific distances. The sleeker J-50 is said to favor extreme low observability, cutting-edge sensor fusion and tight integration with networked drone operations rather than sheer size. Both aircraft families reportedly prioritize onboard AI and autonomous collaboration systems, allowing them to work with swarms of unmanned platforms as standard practice. Programs emphasize extreme stealth across multiple bands and advanced sensor fusion, trying to ensure the jet see first, decide first and shoot first in any future fight. Analysts note that China is deliberately pursuing multiple future fighter paths simultaneously, increasing its odds of fielding at least one successful design on an ambitious timeline. The sixth-gen race allegedly intensified after Boeing received F-47 development work in 2025, giving U.S. industry a visible lead that Beijing is determined to close. Experts say U.S. planners now quietly fear that China is narrowing the technology gap faster than expected, raising the stakes for who fields and mass produces the first truly dominant sixth-generation fleet.